This is a video for AQA Further Pure Mathematics, Vectors section 5.2, using the vector product. Well, we met the idea of the vector product in a previous video, and we said that the vector product forms another vector, hence its name. But what's important about this vector, which is the result of the cross product, is that it is perpendicular to both A and B. This diagram illustrates that if we've got vector A and B and we form the cross product, then n is as shown, being perpendicular to both of those. The direction of n is the direction that a normal corkscrew would travel if we turned it in the direction from A to B. So if you imagine doing that, the corkscrew is going to travel upwards in this direction, hence n is as shown. Now, an alternative form of the cross product is to say that it's the length of A mod B sine theta and then n hat. Now, n hat is just a vector of length 1, so the hat symbol there means length is equal to 1. So it's what's called a unit vector, which is normal to A and B. So look at the similarity between that and the definition of the dot product, which was AB cosine theta, but of course that's a scalar. Here we've got a vector, hence we need this n hat in there. It also means that we have got a formula which we can calculate in two different ways. So we can relate the angle between vectors A and B to the dot product. It also means that if we consider A and B and A cross B equal to 0, then assuming that A and B are not 0 themselves, then that means that sine theta must be 0, and hence the angle between the vectors A and B is 0. So that means they are parallel. So contrast that with the scalar product A dot B being equal to 0, where the two vectors are perpendicular to each other. So this means that given any two vectors, we can find a vector which is perpendicular to both of them by simply forming the cross product. So here we could form the product 1, negative 1, 3 crossed with 2, negative 1, 2. And we can see that from that we would get negative 2 minus negative 3 on the top line. So I was looking at lines, the cross product of lines 2 and 3. Then so negative 2 minus negative 3 is 1. The next one is going to be 6 minus 2, so it's 4. And the bottom line comes from negative 1 minus negative 2, so it's 1. So the vector, which is AB, this is A cross B, where this one is A and the second one B, is this vector here, and it will be 1, 4, 1. If we did B cross A, then it would be directly opposite to that, so this would be equal to the vector negative 1, negative 4, negative 1. Now, because we know that the cross product is bound to give us a vector which is at right angles to both A and B, it then becomes useful in working out the equation of a plane if we know 3 points. So consider this example then. We've got 3 points in the plane, A, B and C. And so we could take the vectors from A to B and A to C, and if we form the cross product of those, that's bound to produce a normal to the plane. So AB cross AC would be a normal. Well, AB is B minus A, so that's 2 and then 1, 1, and the vector which is AC is C minus A, and that is 0, 4, negative 2. So AB crossed with AC is the vector 2, 1, 1, cross product with 0, 4, negative 2, and you can check that that comes out to be negative 6, 4, 8. The equation of the plane then is r dot n is equal to a dot n, where a is a point in the plane, so we can literally use a, which is the point 1, negative 2, 0, and n is a normal vector. Now we've got n here, or we've got a normal vector here, but we could use the fact that we can divide through by 2 to give us negative 3, 2, 4 as being a simpler normal vector n. So that's the vector I'm going to use to say that the equation of the plane is therefore r dotted with the vector negative 3, 2, 4 is equal to vector for a 1, minus 2, 0 dotted with the normal negative 3, 2, 4. Or in other words, we've got that r dot with negative 3, 2, 4 is equal to, and if you calculate the dot product there, minus 3 and minus 4 gives a total of minus 7. So remember then that the cross product between two vectors is going to be a vector which is normal to the two vectors, and also the fact that A cross B is going to be completely the opposite direction to B cross A. And then we can use this to find the equation of a plane, because we can then get the normal to the plane by taking the cross product of two vectors which are contained in the plane. That completes this video on using the vector product. In the next video we'll be looking at the equation of a line using the vector product.